welcome. In this lecture, again, I'm going to kind of go through a combined product and chain rule. Again, really the moral of the story is kind of taking things one step at a time and making sure you're using the right rules where they need to be used. So this is example 2. And we're going to take, so we want to take the derivative with respect to x. So the derivative with respect to, and then this is kind of a variable x, of, and then our function is going to be, so we have the square root of x squared plus 1, so the square root of x squared plus 1, and then we're going to multiply that by e to the sine of x, right? So you can see how we have to combine both, right? There's a product, we're multiplying this times this, but for each of these parts we have to use the chain rule. Okay, so the first thing that we'll do is to apply the product rule, and then we'll see all the places that we're going to need to use the chain rule. Okay, so plan of attack, maybe I'll actually kind of write that. So plan of attack, our plan of attack will be, because the chain rules inside of each of these things that we're going to be multiplying, kind of a nice plan of attack is to, 1, apply the product rule, but not actually kind of work out the derivative. So we're going to apply the product rule. And then 2, we're going to, in taking the derivatives, right, be careful to use the chain rule. Okay, so in taking the derivatives, careful to use the chain rule, and maybe I'll do those on the side. In taking derivatives, carefully use the chain rule on the side. So carefully use the chain rule. And we're going to kind of do that on the side over here. Okay, so here we go. We know what we need to do. So remember we can take, so I'm going to take this part and leave this here. In fact, I'm just going to leave that color to indicate that I'm not taking any derivatives. So x squared plus 1. And then I need to take the derivative with respect to x of this part. So I know I'm going to need to multiply that by d dx. So I haven't taken this derivative yet, so it's good to keep track of this part over here. So I have e to the sine of x. I haven't taken any derivatives yet, so we'll just kind of keep that green for now to kind of indicate this is still the function that we haven't taken the derivative of. And then we need to add that to, and now we just write this on the outside. So e to the sine of x. We didn't take any derivative there, so we don't have to worry about the chain rule there, just like in the other one. And then we're going to take the derivative with respect to x of, and then in parentheses, again, we're going to have, so now we have this one. So this is the square root of x squared plus 1. Okay, so looking at this, we have 2 derivatives to take, and each one of them is going to require that we use the chain rule. Okay, and in using the chain rule for this one, we know that this is going to be so much easier to work with if I write this as x squared plus 1 to the 1/2. Okay, so let's just kind of go ahead and do this. So the chain rule here, so let's work out this derivative. So I have the derivative with respect to x of, let's put a line here. Let's get ourselves organized a little bit. Okay. So when I'm taking the derivative with respect to x of, and I have e to the sine x, right? Then I can keep track of this. So my outside, not going to use all the colors that we would normally use, but my outside is going to be e to the u. And then my inside is going to be sine of x. Okay. So what happens when I take the derivative of the outside? I still get e to the u. Okay, so I take the derivative of the outside, and I'm going to get e to the u. And then, right, I need to multiply that by the derivative with respect to x, right? So I've got the derivative with respect to u. Actually, maybe let's just kind of carefully write this out so we don't make any mistakes. So we want to take the derivative with respect to, add in a color here. Got a lot of things in my hand. Let's put them down. You might probably know by now when I have a lot of things in my hand, I tend to drop them. So we have the derivative with respect to u of e to the u. And then I want to multiply that by the derivative with respect to x of the sine of x. Okay. The derivative with respect to u of e to the u, this is just e to the u. But we'll leave it red so that we remember that we're going to have to put back in our inside, so that's e to the u. And then we're going to multiply that by, and then this is going to be cosine of x. So that's cosine of x. Okay, but we have to handle this u. This u is actually this part right here. So this is just going to equal e to the, and then I have a sine of x, times, and then times my cosine of x. Okay, so I took this derivative, so that's the first thing I'm going to put in over here. This is the square root of x squared plus 1 times, and then I'm going to put this whole thing, right, into here. So I have e to the sine of x times cosine of x. Okay, so I took this derivative. So I'm done with that one. Now I have to do this one. I'll just write the plus e to the sine of x. But now I just have this whole derivative I'm going to have to put in. So I'm going to put some big parentheses here that'll be for that derivative. Okay, so let's go ahead and use the chain rule on this one. So if I want to take the derivative with respect to x, so the derivative with respect to x of, and then my function here is going to be this, so I have x squared plus 1 to the 1/2. So x squared plus 1 to the 1/2. And then, so my outside, right, is just going to be, so my outside here is going to be, so I have, it's u to the 1/2. And then my inside is this u, right? So my inside is going to be, the inside is x squared plus 1. Okay? And so the derivative of my outside, right, is going to be 1/2 u to the minus 1/2. Okay, so I'm going to get, right, so I need my derivative with respect to u of, and then this is actually this red u, so this is u to the 1/2. And then I need to multiply that by my derivative with respect to x of, and then we have x squared plus 1. Okay, so this is going to equal, well, what's that derivative? So that derivative is going to give me 1/2, and then I'm going to keep that u there so that I don't forget that I haven't yet plugged that in, and this is to the minus 1/2. And then I'm going to multiply that by, and the derivative of this is just 2x. And now we have to put back in our u. So this is going to equal 1/2. And then our u is going to be x squared plus 1. And that has to then go to the minus 1/2. And then that needs to be multiplied by 2x. And this could definitely be simplified because I have a 2 and a half. And so this is just going to equal x times, and then I have x squared plus 1 to the minus 1/2. Okay. So now I'm able to put this here. So I have x times x squared plus 1 to the minus 1/2. And I gave myself a little bit too much room there. Okay. And there could be some like cleaning up or simplifying of this, but we're actually done, right? So we can just kind of box that. Boom. Okay. So to talk this through a little bit, right? In the first part, we're just using the product rule, but we're doing it very carefully. And this is why, to kind of do that intermediary step where I'm saying, you know, I'm leaving this alone, I'm taking the derivative of this, plus leaving that alone, taking the derivative of this, because then you're like very consciously thinking about the fact that I need to take this derivative and I need to take this derivative, and you have it there so that when you find it, when you do it in your side work, you know exactly where it goes. In fact, it could help then to do this, leave myself with some parentheses plus this, leave myself with some parentheses so when I'm done, I remember exactly where I'm supposed to put these. So when I do these, I just have to use the chain rule. I have my outside function and my inside function. Again, just like with the product rule, it's good to kind of do these intermediary steps so that we don't make any mistakes and we realize things like, oh, I need to put back in my sign of x and where I'm taking the derivative and not, and so on. Okay, so I hope that made some sense, and I will see you in the next lecture.